All right, so today we're on 2.5 imaginary and complex roots. Do not have to write this first part down, just write the title down. So if we put the graph of f of x equals x squared plus 1, then we'll see that f has no real roots. And I got rid of the graph below because it makes more sense just to see it on the spot. But if you remember from what we've done so far in this chapter, roots are when it crosses the x-axis. The function x squared plus 1 is going to come down to 1, and it goes back up. So it's a very rudimentary graph, but it illustrates the point. It never crosses the x-axis. But if we search, or basically whenever you're finding a root, you're looking for when it's equal to 0. In this equation, being equal to 0 would mean that we had to set it equal to 0 and do x squared plus 1 equals 0. Subtract the 1 over, gives us x squared equals negative 1. And then to solve for x, you take the square root. As we discussed before, whenever you take the square root, you get a positive and a negative solution. So it'd be plus and minus square root of negative 1. All that becomes a moot point, though. That becomes a moot point because if we take the square root of a negative number, you're going to see that it ends up being undefined. No matter what calculator you put it in, it's always going to come back as error or undefined. It's not going to work. So, when mathematicians were working through this material, they hit that problem a lot because there was no real number. There's no number that we can square to get a negative. No matter what I put in, if I square it, I'm going to get a positive number. Negative 1 times negative 1 is a positive 1. But it doesn't stop this from occurring in life. As they were examining different functions, they would continue to come across where we had to take a square root of a negative number. This is why imaginary numbers were invented. The imaginary unit I is defined as the square root of negative 1. And I would write that part down starting with the imaginary unit. I would write all of this down. Big group today. An imaginary number is the square root of a negative number. Imaginary numbers can be written in the form of bi. B is a real number, and I is the imaginary unit. If we square any imaginary number with I, then it's going to give us the original negative number. So if I'm looking at this center column of the table, square root of negative 1 equals I, because that's our definition. Square root of negative 2, we would break it up and do negative 1 times the square root of 2. Then we can take the square root of that negative 1 as I. And so our answer would just be I root 2. Same thing with any number we could plug in here. Negative 4, break it up, square root of negative 1 times the square root of 4. So that would be square root of 4 is 2, square root of negative 1 is I, 2I is your answer. You don't really need this column, sorry. Just do the middle one. Lastly, if I take the square root of negative 1 squared, that would give me square root of negative 1 is I, so that would give me the I squared. And if I just square I, it takes me back to negative 1. Good with that? I don't know why this little triangle's here at the top. Who knows? Example 1a. We're going to simplify square roots of negative numbers. So we want to express this in terms of I. So the first thing I do when I see this is I break it up. I don't want to deal with that negative in the 121 anymore. So I'm going to break that up to be 5 times square root of negative 1 times the square root of 121. Now if I take the square root of negative 1, we just learned that that gives us I. So it would be 5I. And then the square root of 121 is just 11, because 11 squared is 121. So I have 5I times 11. I can still multiply my real numbers by each other. And I end up with 55I. That's it. This section actually isn't too hard, other than the fact that we're talking about imaginary numbers, numbers that can't be real. All right, so what's the first thing we would do here? Yep. We just make it negative 1. So we're just breaking the negative 1 up from the 96. Yep. Now, what's the square root of negative 1? No. Well, if we do negative 1 times negative 1, that gives us a positive 1. So that wouldn't be negative 1. This is where the trick comes in. That's got to be an I. So anytime you see the square root of a negative, you know you're going to have an I in the answer. Yep. Yep. And that could be 2 and 24. Yep. And 6 breaks down to 2 and 3. 4 breaks down to 2 and 2. Now we just do our pairs. So we have a pair of 2s, and whenever we have a pair, just one of those 2s comes out in front, right? If we have another pair of 2s, so that comes out here. And then these 2 are by themselves, right? No pair. So that stays inside the root. So 2 times 3 gives us 6. Stays inside the root. And then that 2 times 2 out in front just becomes a 4. So square root of 96 broke down to 4 root 6. And then we had this from out front, from this part of it, and it just comes down. So the negative would go in front of the 4, I root 6. And that's our final answer. Well, complex we're going to get into. This is just imaginary portion of it. All right, so now that we learned that portion of it, we're just going to take it a step further, and we're going to actually solve an equation with it. It's really the same exact concept. So the first thing that we have to do is we have x squared equals negative 144, right? So how would I get rid of this squared on the x? Now we would do that if we were trying to factor. You can just take the square root. If I take the square root of this side, that cancels out the x squared, or the squared on it. Whatever I do to the left, I have to do to the right side. So take the square root of the left and the square root of the right. That's just going to give me an x here on the left side. Now on the right side, I have to break this down, this negative 144. So now this part of it is just like what we just did. So if I take the square root of negative 144, what's the first thing we did? Separate the negative. Yep, separate the negative 1 out from the 144. Yep, so square root of 144 is 12. What's the square root of negative 1? Yep. So now this is just 12i. Square root of negative 1 is I. Square root of 144 is 12. The only difference is, once we put this x squared in here, it always gives us two solutions. Remember how we always ended up with two solutions? So you just make this a plus and minus, and that finishes the problem out. Let's try another one. You like how it always gets one step more complicated. So our whole goal is to get x by itself still. So what would we do first? Yes, subtract the 90 first. So it gives us 5x squared equals negative 90. Then what do we do? Yep, divide by 5. Good. Yep. They're 4 steps, sometimes 5 steps, with imaginary numbers. What do we do with this negative 18? Right, we'll break it up first and put the negative 1 and then 18 and break that up. Yep, factor it out. Yep. Yep. So the square root of a negative 1 gives us the I. 9 brings the 3 out in front, and then it's the square root of 2. What's our last step? It's just the plus and the minus. Good. Pretty good. There will be some homework tonight. It'll be a little bit of the stuff we did before yesterday with rationalizing denominators, and then some of these problems. That's it.